Hello everyone, welcome to our weekly reading session. And everyone is welcome to join. The details are in the description below. Today we are having Yijia Shao and Yucheng Jiang from Stanford, and they have a wonderful paper that they wrote with a big name, Professor Monica Lam. And this paper assisting in writing Wikipedia-like articles from scratch using large language models. This paper is focusing on teaching computers or LLMs to write long, well-researched articles like those ones that we see on Wikipedia. It is pretty impressive and pretty nice one. Read the discussion and let's dive in.
They don't know they are unknown about. So I think he will take over for the second part. But to begin, today we are really excited to share our recent work on the Storm project, which we hope are kind of revolutionizing the knowledge curation process in the era of large language models. And in this talk, we will mainly cover our two papers, which are published in NetCode and ENLP this year, respectively. And yeah, let's start it. And feel free to interrupt us if you have any questions in the middle. So what's the motivation of doing this work? Why we still want to revolutionize or change the knowledge curation process, given that we actually have pretty good search engines nowadays? For example, if you go to Google to search our project name and saying, oh, I want to see the open source code, the Google can quickly return the first entry is exactly our GitHub repo. And also before coming today, I searched your university name, and also now Google search, they optimize this kind of experience. So it can give you a pretty nice summary of what you are looking for. And also, I think starting from 2022, we are also seeing QA style chatbots. They are also getting smarter and smarter. So for example, before coming to the talk, I just chat with GPT to say, okay, now I need to give the talk at your university, and do you have any suggestions for me? So this kind of chatbot, they are pretty nice in knowing a lot of information about the world, and also they can support this kind of multi-turn conversation. So my second question is actually based on the first one. And also this is the first screenshot is took from using the OpenAI ChatGPT model, but also over the past 2 years, we are seeing better and better open source counterparts. For example, this is one model, like I think it's like a SOTA open source language model, which is from the Meta Llama team. So I also asked it, okay, can you give me a very concise definition of knowledge curation? So this query requires to understand what this term means, and also being able to really follow my instruction. Don't give me a long paragraph, but a very concise definition. And it seems like it can also do a pretty good job to help me find the information that I'm seeking about. So it seems like today we already got this pretty good search engine and also pretty good chatbot. However, in this work, we are thinking about a meta question. That is, are people's information needs already satisfied? In terms of this, I think if you think about sometimes your information need is not this very simple query, like I just want to know a little bit about the university I will present my work on, or I just want to have a very concrete definition of the thing I want to look for. A lot of time, our information need is pretty vague. For example, I think now people are pretty serious about sustainability, and even at Stanford, we are having a new school. They are dedicated to study this issue. So suppose now my information need is saying, okay, I want to learn about sustainability, which is a pretty large topic. Then if you just try to chat with language model, the challenge may be you don't even know how to start a conversation. Maybe you can only start with this, but you run out of your question because you don't really familiar with this topic. It's similar to sometimes when the reason why people still need to go to see the doctor when they are sick is even though you can search all those books or search all the information online, you don't know what's the good starting point based on your current situation. So then when you really go to search on the internet, probably what you expect is instead of seeing maybe some ads popped up in Google, you hope to see like the first entry, maybe a Wikipedia-like article. So I think Wikipedia is a very good example of what we are talking about, like the concept of knowledge curation. So if you look at how human curate this kind of content. I think Wikipedia is a very amazing project. They have been functioning for around like 20 years now, and it's like an open source efforts. People are contributing from all over the world to curate different entries for different topics we care about. So if you look at their content, you'll find it's definitely pretty comprehensive for this topic. If you look at the contents of tables, it covers a lot of information. And also, a very important thing is pretty organized. Instead of just concatenating all the sources together, it's try to organize the information into different categories. So suppose I'm specifically interested in like what's the transitions in people's understanding of sustainability. I can directly go to the corresponding section without needing to read all the citations here. Another cool thing is also it's pretty reliable since it's generated tags with citation. If you want to check one part or want to learn it in depth, you can quickly go to the link to know more. So it's also allow humans to verify it. And also Wikipedia, they are doing a pretty good job by leveraging the community efforts to fix some misinformation if they are detected. However, there are so many topics in the world, and it's impossible basically for, even if we have all the people from the world they are contributing, it's basically impossible to let humans to write every topic we care about on Wikipedia. Especially some topics, they are not like needed by everyone in the world, but specifically I am curious about. So for this type of topic, if you go to search on Wikipedia, very likely you cannot find a good entry about this. So one idea or motivation of our work is, given the main bottleneck of creating this kind of high quality content is we don't have enough manpower to write article about all of them. Is it possible now we have powerful AI models? Is it possible to build AI system or construct algorithm to automatically generate them? So when we just start with this idea, I go to directly try the current language model since they can follow our instructions. So this is the example I try with the latest model from OpenAI, which I think some sorts of representing the highest quality of model output we can get directly out of the box. So the topic I'm interested in is, in the era of AI or this kind of modern model, can you help me write a Wikipedia article on the future of work? And after thinking for a while, the model generates indeed a pretty long article. However, if you compare this type of article with what human curates for equally complicated topic, you'll find one major problem is they don't have this kind of citation. So even though you have all the content here, it's very hard for me to verify whether they are correct or not. And also, if I want to learn more about a specific information, I don't know where I can find the source information about it. And another thing is, if you take a quick look, browsing what the model generates, you'll find it indeed touches some general aspect. However, compared to the human written one, it lacks of details. Very likely it's because these models, they are usually pre-trained on web corpus. So their desired behavior is to output token with the highest probability. So this type of content, they are usually correct, but they are pretty in general. So they don't have all the details we care about. So in this work, in our recent work on Storm, we try to craft a better system that can turn the user-given topic, which don't have enough detail, directly into a Wikipedia-like article with comparable depth and breadth with the human-written Wikipedia article. And in our experiments, we are also gathered some experienced Wikipedia editors to get their expert feedback. And we are pretty glad that they think this tool could also help for their pre-writing stage to help them create more high quality content to feed the Wikipedia platform. So how do we do this? Why by building this kind of a system, we can potentially generate grounded articles with good breadth and depth. By grounded here, I mean it's like the articles we generate, they come up with this kind of citations. So it's more verifiable and easy for people to go into details. I think one key idea we have when developing this system and doing this work is we are really trying to see how humans are doing this thing. So one key idea we have is okay, given it's very hard to directly use one single input to instruct the model to do what exactly we want, can we take a look at how human writes this type of articles to ensure they are have a good coverage? And it's pretty lucky, like I think in the last century, before people started to interested in computer science and artificial intelligence, there are many work at that time. They are looking at how to teach humans to write better. So they are not teaching model to generate content, but teach human to generate content. And there is a specific work coming up last century. It's describing like for human, before we go to actually write the article, we actually spend a lot of time in the pre-writing stage, which means like even before we can generate any content, we spend a lot of time trying to discover the information and have the process of trying to organize them even before our writing starts. And then also another interesting thing, since I am also a graduate researcher, a lot of time I'm also reflecting on how I am doing this kind of information discovery or literature search. I think one key point is a very core part about searching all the information is actually not finding the answer, but the process of asking good questions. So this actually also, I think, kind of be useful for our work, because you can imagine if our system has the ability to come up with very good questions, then since we have very good search engine and very good language model chatbots, as I said before, we can directly use them to get the information we want. So basically the bottleneck now is we really need to make our system being able to ask good questions without human providing all the initial questions. So based on this motivation and the idea we have, we try to break down this pretty complicated problem, which is, oh, we only have a topic at the beginning, and we want to let a system to produce a full-length article with citations and good breadth and depth. So we break it down into the two stages, similar to how human is doing all the writing. Is before we go to generate the full-length article, we focus on the pre-writing stage, where we try to use the model to first collect all the references and curate an outline to later organize the information into the article. So as you can see about this pre-writing task, it's also pretty challenging. I think it's actually the most challenging part in our whole system or in our whole work, because once we have all these references and the outline, it's not so hard to get the full-length article given the strong generation capability of the current models. However, in order to do the pre-writing task well, the system needs to be able to do multi-hop search so it can get a very good set of references. And it also needs to be able to do what people so-called concept induction, because once you have maybe 100 references, how you can group them into meaningful section heading, this is also non-trivial. So based on what I just said, it's like there are so many challenges here, but what's the most important thing we need to resolve? And by drawing inspiration from how humans do literature research, we're thinking about, okay, maybe the bottleneck is we need to improve the system's capability in asking questions. In this way, like we can just connect it with other search engine or chatbot to fulfill the other parts. So one basic idea we try at the beginning is, oh, given we just hope the system or the model can give us some questions, can we directly just use prompts? Since you can just ask the model, oh, say I have a topic, please ask 30 questions about it. Definitely the model will give you some questions since they are capable of following instruction very well. However, we found if you look at the question it gives, usually it's about those kind of what, when, where questions. So those questions are not very, very interesting. You can imagine if I just search one basic information, you can satisfy all the questions listed here. So that's why one takeaway we learn from this part is if you directly just use prompt to naively ask the model to come up with questions, even though you can prompt it multiple times to get more output, probably we can still very hard to find those high quality questions. So what we are doing here in Storm is we try to, instead of directly prompt the model to come up with question, we try to mine out some perspective in researching this topic and use such perspective as a latent variable to control the question generation process. So by saying the perspective here, you can imagine given the same topic for human when we want to explore it or research about it, different people come with very different backgrounds, so they have different focus. So for example, for the question of, for the topic of sustainability, you can imagine if I am an economist, maybe I focus more on how this type of sustainability will influence our economy. However, if you come with the background or the perspective as a social scientist, then probably you will come up with the question related to the social aspect, like focusing on topics such as social sustainability. So in order to obtain all these perspectives before the system go to do the actual search, we actually try to leverage the existing content on the Wikipedia. So even though there is no exactly the article about the topic we care about, usually there are some adjacent topic on the Wikipedia. For example, for sustainability, you may find some article about sustainable development or corporate social responsibility. So we gather all those content and first use language model to prompt it to generate some perspective. Basically, we will say, oh, given these are some background information about this topic, and now you want to research about it, can you give me different perspectives or different stakeholders that may have different interest in exploring the topic? So this is how we obtain the perspective. And after we obtain it, we basically, instead of directly prompt and say, oh, ask 30 questions about the topic, we will give the model this kind of persona saying, oh, you are now a social scientist and you are interested in exploring about sustainability. Please come up with questions to research about. So this is one change we did compared to directly use a model to generate question. And another major innovation or major takeaway we learn when doing a STONE project is sometimes in-depth questions, inherently they arise only after reading the information gathered in previous rounds. So here's an example. Say I want to learn about the Winter Olympics opening ceremony. Probably this is an initial question I'm able to come up. Oh, I'm curious which countries are participating in it. However, after reading the answer, which mentions, oh, these countries, they enter the stadium in a specific order, I feel if you are a human, now it's pretty natural for you to just be curious, oh, how the order they are determined. But you can imagine for the second question here, if you never see any information about this Winter Olympic ceremony, it's very, very hard. Like you have a high probability to come up with question. So it's basically the same thing with the language model, since they usually produce the outcome with the highest probability. So we will try to mimic this kind of multi-hop human information seeking. So basically you can imagine in the first step, we give this Wikipedia writer a perspective, so it can now generate more high quality questions. But then in order it can have multi-turn information seeking, we simulate the conversation between the Wikipedia writer and an expert model. This expert model we implemented as just a QA question answering system. So now if once you have a question, the question answering system can give you an answer. So this process can keep going to support the multi-turn information seeking. So this is basically how our system works. Once we gather all the information, we prompt the model to come up with an outline. And finally, based on the outline, we can write section one by one. So after we do this work, we are curious to know, oh, whether we are really doing a good job. So we do two types of evaluation. The first part is we focus on the outline quality, since we just decouple the problem into the actual writing part and the pre-writing part. So the outline, how we evaluate the outline is we specifically select the topic that already have Wikipedia article on the internet, but those articles, they are created after the training cutoff of the model we evaluate. In this way, we can make sure our model never see these articles when they are trained. However, we have the human ground truth to compare with the model generated article. And we just extract the two sets of outlines from the human written one and the model generated one. And we compare some soft record to compare two sets of headings. And specifically, we care about whether the entities, because they usually condense the most concrete information in the outline, we also compute the entity record. So our results show, compared with some baseline, basically you can naively ask the model to generate an article at a show at the very beginning, or you can just use a topic to retrieve some information online and concatenate them to do this type of generation in a retrieval-augmented generation way. So by comparing with all the baseline, we found our system has better quality in the outline stage. And also, since we introduced these two innovative points, which is giving models some perspective and also simulate the multi-turn conversation, we conduct ablation study to see whether these two techniques really help. And we found indeed, if we remove either one of them, we will see a very significant performance drop. Besides the outline quality, since it's more like a proxy to see whether we are doing the thing in the right direction, we mostly care about how human perceive the model-generated article. So at the end, we did a very careful human evaluation by really posting an ad on the Wikipedia platform to invite Wikipedia editor to join us to help us evaluate the quality of our article. And we are pretty glad to see they also prefer our system much more than a baseline, and also say, oh, they really want to use it in their pre-writing stage to help them create article to feed the Wikipedia. So this is basically what we did in the Stone paper. So if we revisit our meta question, this system tries to satisfy people's information need. So now you don't need to come with very concrete query. You just have a random question or a topic interest in your mind, and our system will curate all the information for you. However, when really testing our system, we also get some feedback saying, oh, after I input my first topic, my source actually evolved. So I may want to update my query. Or some people will say, okay, when looking at how your system is functioning, when I look at all the links it's discovered, I'm inspired by this specific link and I hope to learn more about it. Or there are people, they may already come with a lot of information about the topic. So they may say, oh, I actually also know this topic. I know this article I definitely want to include in the final report. Can you include it? So these are the very natural feedback people have when they use our system. Unfortunately, for Stone, people cannot do all this because, as I just described, the only part the human can interact with the system is providing this kind of input. So they cannot interfere in the process the system is working. So this is the motivation of our second work, which we try to allow humans to really collaborate with this type of knowledge curation or information seeking system to help us, to help them satisfy their information need better. And this part is led by Yucheng. So I think now I'll just hand it over to him. Yucheng, can you directly share the screen maybe? And you are muted now.
Yeah. Can you see my screen?
Yeah.
Okay, so maybe we can pause here, like to take any questions if everyone have right now, for the first part that Ija shared.
Yeah, sure. I thought I would ask it at the end. Yeah, I was wondering about Storm. You talked about the in sort of prompting, but then the feedback that you want is a question from Storm. And
yeah,
we see that prompting even when we are using like GPT, and sometimes it is sort of like you want some guidance on the subsequent questioning. And my question is here in custom, when you do that prompting and you're seeking out the response you want is a question, what is the goal of that? I missed that.
Yeah, this is a very good question. You can imagine our final goal is we want to gather all the relevant maybe information online about this topic. But if you just use the topic, for example, sustainability, to retrieve, like call the retrieval model or call the search engine, usually you can only get very limited material because after maybe the first top 10 entries, the other part, they are not of very high quality. So the reason why we are more interested in prompting the model to ask questions is, you can imagine, if I can really get a lot of high quality questions from the model, then we can use those questions to retrieve information. Basically, if the model come up with a question saying, oh, what is the social aspect in social sustainability? We can use this question to query the search engine or some question answering chatbot. This is much more concrete than the original topic. So usually it will lead to more high quality information. And also, suppose given the initial seed topic, the system can generate multiple questions. Then this also allows us to gather more information to have a better coverage. So that's why in this work, we're specifically interested in seeing how to really teach the model to come up with meaningful questions to research the topic.
Oh, wow, that's interesting. Then another thing is, when I looked into the paper, I'm seeing some component of RAG, and
Yeah.
in my mind, I was like, if the model is not trained on maybe latest data, but that data is accessible on the web, it's entirely going to depend on the search. For example, if we need latest information about a celebrity and maybe their biography, that would mean that all the search is going to be from the internet, from the web. And
Yes.
and we are sure that it's going to cite the relevant references or articles.
Yeah, this is a good point. So basically, your understanding is pretty correct. So basically, a benefit of RAG, this kind of retrieval-augmented generation, is it allows you to incorporate the latest information, because the search engine, they are usually up to date if you think about Google. However, a thing about it, I think your question is like, Dan, since the model never see this question or topics before, how do they know like what the question they should ask to know about it?
Yeah.
However, it's like, you can imagine, for example, suppose today I want to report a specific celebrity, which the model has no idea with. But in the first round, we are basically first present the model with some adjacent article. So you can imagine if the celebrity A, it doesn't know, but we first show it some article about celebrity B and celebrity C. So usually like how people cover, write article about them, they share some very similar feature. Like usually you talk about their education background, they talk about their achievement. So these are high level things that a model can, this topic share. So this information allow the model, if you prompt it to come up with a perspective, it can basically do this kind of in-context learning or learn from how humans write about existing topic. So it can come up with the question to talk about the celebrity A, even though it does not know celebrity A before. So basically, this is, I think, a good thing about this kind of generation ability of the current model. It can learn about how humans write about B and C, and then now it goes to write A.
Impressive.
I have a question.
Yes.
Yes, Hijia, how are you? I appreciate you meeting us and your team, please. You talked about mimicking human writing process. I appreciate that AI has been advanced to the level where a lot of work can be done using AI. But how to humanize writing? I've seen that, for example, if you look at the content of ChatGPT-4, which is the latest. Critically, I'm a researcher and I've made some publications at an international level. So depicting the perfection in academic writing, the AI tries to imitate what humans do, but there is a little bit of imperfections. I don't know if you can still also, yes. So you can easily tell that this document has been written by AI, and still you can tell this document has been written by a human. So what do you elaborate more about that? Because I've seen that a lot of improvements have been done. There's a slight gap. There's a slight gap. Yes, please.
Yeah, I agree. I think this is a good point. Currently, I think the AI is still in the stage that is not it's as good as like human expert in, for example, writing really research paper. I'm seeing some companies trying to automate this kind of research. However, their quality, if you ask me as a reviewer, I will definitely don't think I will accept those papers. So for the first question, I think the AI is still not in the stage that can directly replacing the human, for example, writer or human researcher. However, the reason why I say one motivation when doing this work is mimic the human process. This is more from the system constructing perspective. So you can imagine, for example, if I directly give all the topic, I can write a very extensive prompt saying, oh, please, you are a Wikipedia writer, you need to follow the Wikipedia guidelines to produce an output. However, usually if you use this to prompt the model, its performance is bad because the instruction is very complicated, and also it does not have all the information to write, since, for example, it does not know the latest information. So we try to use how human break down the writing process, this kind of different stage human come up to really construct our system. So you can imagine we break down our system to, before the actual writing happen, we go to do this kind of question asking and information gathering. So for this process, like how we decouple the stage, this part is drawing inspiration about how human write. But for each specific module, like how to ask question, how to answer question, how to come up with outline, and how to finally write the article, each different specific part, we are trying our best to use the latest model to achieve the best performance, but it's not specifically say, oh, it can definitely ask as good question as the human expert can already ask. So this part, I think, is still has room for improvement. But overall, the takeaway is potentially we can learn something about how humans decouple their workflow to construct our system.
Oh,
Hope it answers your question. Yeah.
Answered it well, actually. Thank you.
Thank you. Ichia, I don't know. The next question I had was about the model. I've looked at the model code, but not comprehensively. And maybe, I don't know whether you can answer it now or later, about the model architecture and some of the internal implementations. I don't know overview, but also I'm particularly interested in the training process. If I don't know whether this can be now or later.
Yeah, I can briefly answer this and then can shift my turn to Yucheng. Basically, for the model training part, in our experiment, we are mainly using like this kind of already existing pre-trained model. But I think currently for the architecture, most architecture are basically transformer model. This part hasn't changed too much. But I think an interesting thing to try is, for example, for our Storm paper, the reason why we didn't retrain the model is because we focus on general topic, like the information they are grounded on the internet, and the topic we test, they are also daily topic, like people would be interested to search on Wikipedia. But after releasing this work, we see some people interested in leverage it into some subdomain, for example, in education or in medical care. So for this type of domain-specific subject, I think it's may worthwhile to fine-tune the model, for example, specifically for the question asking part. Because for the generation part, usually there are so many things to share, like how you write a article about medical or write an article about education. It's not so much difference, but basically you follow all those guidelines. But how to ask a domain-specific question, that module, I think, has some room for improvement if we want to really deploy Storm for some subdomain. So that part, I think, also may worth some model training. But currently, the model architecture, we are not like trying to inventing a new architecture. And also, I feel the current architecture, they are good enough to do this kind of job. Yeah.
Oh,
I think we can maybe hand over to Yucheng, and we're happy to take more questions at the end as well. Thanks
yeah,
for all
sure.
these meaningful questions. Thank you.
Sure.
Yeah, so the second part of the talk talks about the extending the existing storm into collaborative storm, which we called co-storm. So basically, like in the existing information seeking application, especially like Storm, such application that writes a long form grounded reports that cover the breadth and depth to some extent. Such reports are good at like bringing some insights about like unknown unknowns. Basically, like it brings up information that you are not anticipated at the beginning of your search and brings new insight and new perspectives. Such reports, one great example is like Wikipedia articles, but they are very hard to get, and it takes like a lot of human efforts to come up with even one good article. So Storm kinds of make it easier for people to request any reports on any topic within just a few minutes. But such reports are like cover something about everything. So sometimes it's hard to tailor to each individual's need and their interests. So like we think about like what are existing like scenarios in our real life that we can be involved in such discussion that covers something we're interested, but those discussion involves experts talking to each other. So we're thinking so like such scenario is like students talking to their professors, children listening to their educated parents, or even like we listen to like domain experts talking on a specific topic we're interested in, and we have the chance to engage and ask questions to them, and injecting our thoughts and to drive the conversation towards something we're interested in. But we can imagine like such conversation, like it's not everyone have the privilege to be involved in such discussion in any topic we're interested in, and it's quite expensive and a very rare resource. So we're in this work, we are trying to make such experience available to everyone on any domain at a very low cost. So for a more theoretical grounding, such information like searching or experience involves in a berry picking technique proposed by Bates in 1989. Basically, this technique stressed that the information search process is not just a single query to satisfy to return a single set of golden answers, but it emphasizes on the process that leads to the final results. So people are collecting a series of references that they are interested in, and they may refine their queries as they see more information. And the whole idea is that people will picking up most important things that are like meaningful to them, and they will evolve their query. So there are three insights here that in complex information seeking, there is no single answer that can answer original question. And people may have dynamic involving queries. People collect useful references along the way, and this process allows people to explore unknown unknowns, which brings insights that they are not anticipated at the beginning of their search. So some key design philosophies here is that it's a mixed initiative design that goes beyond the system initiative like Storm like application, which you give the topic and the system will do the rest. And it's also unlike the user initiative like the search engine or chat with the chatbot, where you're leading the process, you're proactively asking questions and the AI just passively respond to your question. It's kind of the mixed initiative where you can either choose to listen to the system to bring up new insights or actively engage in once you have more thoughts and you want to drive the conversation. And during this process, it invokes thought-provoking questions to lead the people to think about different perspectives, different aspects there that they are not aware of. And since this process, you can think it's quite cognitive, the cognitive load is quite high as you're exposed to so many information. Is there a way to scaffold human throughout the process and to organize all the information along the way? So under such context, we propose CoStorm, which it has emulate the roundtable conversation containing human and multi-language model agents. Those language model agents take two different roles. One role is language model participants. they will ask questions to each other and answer questions on grounded sources. To do so, they generate such new search queries, retrieve information from the external sources like the private corpus or the internet, and they will update the mind map with the collected useful information that help people to visualize the involving concepts and help users to navigate to if they want to review the chat history. And the second role is the moderator. It's a guiding role. Basically, they provide some thought-provoking questions to encourage the users to diverge from their initial search path and make the conversation more interesting and cover more broader aspects. And this dynamic basically not only encourage the serendipitous finding, but also align with the user's evolving goals and interests. So let's dive into some pipeline design of both roles. So for the language model participants, they will review the conversation history, and they will decide its intent by either asking questions to other agents, or they will answer a question posted by previous agents where they want to bring insights about something they would prefer. So they will generate the search query and then retrieve from the external sources, filter the source, filter and only keep the trusted source and re-rank them as needed. And based on the retrieved sources, it will generate a cited response. So both asked question and generated response will go through a polish round, which will make the utterance more conversational engaging. And the cited response will be updated to the mind map, which we'll cover later. So let's pause for a while and think about what actually lead us to the serendipitous finding as we browse the internet. So while browsing, we might come across something that is relevant to our initial search query we type into the search engine. But that is not directly something that is not directly related to our search query, but that is something relevant to our general interests. And we will sometimes click on that link, those sources, and it will cause us to deviate from our initial search path and redirect our interest into some other aspects. So that's when we find, okay, those aspects are really interesting, and I want to know more. That is when we have the so-called serendipitous finding here. And the moderator role here is try to emulate such experience in the CoStorm system. So let's review the conversation history here. The language model participants we just discussed, they will collect information and generate their utterance. The collected information are not all used to generate the utterance. Some of them are used and some of them don't. And the moderator will take a look at those unused information in the conversation history. And they will be re-ranked based on its usefulness, which should be aligned with the user's interests, but not directly related to the search query that leads to its original retrieval in the conversation history. And combined with the information from the mind map, basically give us an idea of what has already been discussed. It will provide thought-provoking questions that brings new perspectives into size and lead the human or the participants to think from a different angle. And of course, it will go through another round of polish of the utterance to make the utterance more engaging. Then, as we said, the conversation will expose so many information to the user, and we want to organize all the information into concepts where the discussion focus along the way. And we maintain a hierarchical concept-oriented mind map dynamically. So basically, it will take a look at the used information and will insert the used information to the mind map by finding the most appropriate concepts existing in the mind map. If it doesn't, we just create a new one. And as you can imagine, like as the discussion goes, some concepts will be supported by a lot of information. And that's when we want to expand concepts into sub-concepts. And as the user request a report, a storm-like long-form report that cites external sources will be generated on demand. So such reports will take the structure of the mind map. Each section and subsection corresponds to original concepts and sub-concepts in the mind map. And it will leverage the concept name and supporting information to generate the corresponding section. So that's basically the same paradigm adopted in the storm. So I'll briefly go through the evaluation and leave some QAs at the end. So to conduct the evaluation, we leverage Storm, in which we host online for a few months, and we're lucky to gather many topics in the wild. And we downsample such information collected through the hosted Storm application into 100 complex information topics. And it covers 24 fine-grained categories in 6 domains. And one such example is pasted here. As you can see, it's the topic. Basically, it cannot be answered by a single question, and there's no explicit report online. So, the primary evaluation we'll conduct consists of human evaluation and automatic evaluation. For the human evaluation, we basically recruit 20 participants, and participants are randomly split into 2 groups. One group compare CoStorm with Google search, and the other compare CoStorm with the React chatbot. Basically, it's something like ChatGPT, but grounded on the internet. The participants are asked to seek information on 2 topics, one on each system to compare. And both topics share the same domain and share the same goal. After engaging with both systems, the participants are being asked to grade the information seeking with the rubrics along like the relevance, breadth, depth, and serendipity. And the same dimension are graded in the automatic evaluation as well. And we find that participants rate the CoStorm outperform both baselines across all metrics here. And additionally, we also asked the participants to provide pairwise preference comparing CoStorm with the search engine and the React chatbot. Participants find CoStorm that requires much less effort, enable people to engage more, and effectively address the echo chamber issue. Most majority of the participants rate CoStorm provides a better overall experience as compared to both baselines. And since in this study, we introduced 2 types of role of the language model agent. One is the language model experts, and one is the moderator role. And we want to study if how like both role contributes to the overall quality. And we evaluate along the dimension of the novelty, whether the conversation session is aligned with the user's interest and reduce the repetitive information bring into the side of the user. And we find that even with a single expert and a single moderator, such configuration already brings the most benefit of the full configuration, emphasis on the important role of the moderator and the robustness of the reduced complexity of the CoStorm design. So some takeaways from both Storm and CoStorm here is we built language-empowered system for knowledge curation that we propose an emerging paradigm to get in like single outputs from the model to build a system with them empowered by the language model. And we design mechanism to support human agent collaboration to make it more aligned with the human's preference and interests. The rationale is that the language model agents are powerful, but the the final goal we are aimed at is to satisfy the user's need. So in the study of the cold storm, we find different roles in the human agent team could potentially lead to better performance. And for both study, we conducted the user study in the wild, in addition to the controlled experiment, including our paper. So both of them are hosted in the wild and public available to the world. And right now, I've tested over 150,000 users and generating about 500,000 topics. And yeah, we encourage everyone to try the demo, and we appreciate any feedbacks. And yeah, we can leave the rest of the time to the QA.
Thank you, Yu Cheng, sorry. Wow, this is quite interesting. My first question is, I hope I'm audible enough. My first question is about how would custom fare or perform if we take it on domain specific articles like maybe medicine, maybe finance or law. I don't know whether the evaluation was done, but it came to my mind like if we want to customize it to maybe company specific data, and these companies want to easy put up their writings or reports in financial reports or legal reports, things like that. What would you say about its performance?
Yeah, so that's a very good question. So the first one is the system design level, which both Storm and CoStorm basically has two primary components. One is the language model component, which language model we use. And the second big component is where the information comes from, which we refer as the retriever system, where the information will be retrieved. And our repo basically make it very modularized. So you can plug in with different or customized retriever module, and it supports like many language models. Most majority of the models exist right now. And the second one is making it more domain specific or domain more aligned with the specific use in different domains. That question is quite resonant with what Ija just said in previous QA. Basically, I think the primary things that needs to be changed is how it can ask like domain-specific questions that is meaningful to that domain. Right now, it's general domain, and I think the language model are trained on so much data so that it can have a good awareness of what is the general topic looks like. But if you're writing financial reports, you're using it in academic, like writing or doing literature search, such like information seeking requires like more domain-specific questions being asked. And I think that module can be improved. And another bottleneck we see is actually the retriever quality on the private corpus or the more domain-specific corpus. It's like right now we leverage the retriever system. Basically, it's the Google search or the Bing search, which is being optimized for a long time by the companies. But for retriever modules on the customer's corpus, let's say we retrieve from academic papers, that retriever needs still have a lot of room of improvement.
Wow, that's a nice one, and I think the last one would still entangle into that same question, and mainly my thinking is about the industrial applications of custom. Sometimes I think we are generating these articles, and maybe you have other specific data types apart from text. Could be an image, or mainly let's think about the image mainly, because it's the one in most cases that entangles with text. Can it deal with images at any sort of level, or?
Right now, both Storm and CoStorm primarily focus on the pure textual data.
Okay.
So by incorporating image, it involves some visual language model and brings the multimodality. It's definitely a very interesting direction to explore. The reason why we right now we stick to contextual data is that this is the beginning proof of concepts, and we want to make it more in a controlled experiment way. And eventually, I think making the visual data included in such information seeking process is definitely a way to go.
Oh, that's interesting. And thinking about music generation, because as we prompt a lot, for example, I ask Custom to give me a song in a certain genre, and maybe I guide it to the type of lyrics that I might want. I want to assume that I would still get a song as I'm guiding the custom into the specifics of the lyrics, and at the end of the day I might have complete lyrics of the song from custom.
You're saying that you're trying to generate a song or just collect
Yes.
some existing song?
I'm asking, I would get a song from custom through a process of guidance.
That is interesting. I think I'm not sure what's the existing music data will be look like if you specify what's the genre and what a specific style. I'm not sure if that's widely available and associated with the description of each song. If that exists, if you just make it specific to the co-storm, it might retrieve information saying that, okay, I want a song from which country, which language, and which genre. It will give you some songs available online, I guess. But we haven't conducted experiment in this perspective.
Okay. Lastly, with the existing code base and all the resources on the GitHub repo, what would you say some of the possible downstream tasks that someone can perform with custom, some of the downstream tasks that you might think of that can be done?
Yeah. I think it's right now since CoStorm launches about a week and a half, and we are still seeing what are different use cases and topics people are interested in. And what insights we gain from both Storm and CoStorm is that people are using it for a more serious use case instead of the chit chat. And it basically is curate a lot of novel work, a lot of useful information by browsing tons of the insight, websites available online. So basically, it's generating a very high quality reports on so many topics that either performed solely by AI or performed collaboratively by human and AI in CoStorm. So if the people wants to kind of search for a topic, let's say if I search for diabetes, the treatment and the cost, you can actually find more than 500 such articles that people ask in the Storm and CoStorm. And I think such experience will be boosted by the Storm and CoStorm, and you can actually browse the collections that are all the other people's are generated, right? That is one of the add-on benefits if so many people are using Storm and CoStorm and curating different topics they're interested in. And second one is that we're imagining CoStorm right now is only textual based, right? And extending it to more the real conversation with verbally will be much more interested and offer real-time engagement. That will streamline the process more. Yeah.
Wow.
I have a question.
Yeah.
Yes, I have a question. I think Yu Cheng. My background is statistics, and we talked of human evaluation, and I've seen you use the Likert scale ratings. What was your sample size, please? And which reliability checks did you use to articulate the Likert scale, please?
I'm so sorry. Could you repeat the question?
Okay. I've seen you are under human evaluation. What was your sample size? What was your sample size under human evaluation?
My insights?
Your
Or
sample size, the number of people you included.
sample size, 20 people here. 20 people.
Okay.
So can that be used to estimate the entire population to give an expression of the entire population?
Yeah, that's a good question. So those 20 participants are hired online, and the age distribution from under 25 to over 50, and the education background comes from the bachelor's degree to doctoral degree, and we agree like 20 people are not like that sufficient to make it representative to the whole public, but we hope it can provide some insights at the beginning of this research. And that's the reason why we deploy both Storm and CoStorm to the public, letting like more than 100,000 people to try. And we have collected so many feedbacks, and and I think the later parts, that's the part that we have like more insights and make the study more rigorous.
So should we expect more people to be recruited into the forthcoming research, please?
So you mean where those participants are recruited?
Like we should expect more people to be participated to increase the number. Okay, so and my second question coming to the how we dealt with Likert scale data. The next slide. Next slide, please.
This one?
Yes,
This one?
yes. How did you deal with that? Because statistically, when we are dealing with Likert scale data, we find a problem of unreliability. So that's why we go through reliability checks like Cronbach alphas. So how did you deal with the reliability within the Likert scale?
A scale of the human variation here.
So there, please.
This one?
The previous one. Also that
This
one. Yeah, that one.
Okay. So at scale, basically, it's like we in the Storm hosted version, we provide the option for all the participants or the users to provide feedbacks and evaluations on a turn-by-turn basis. They can provide their insights in any turn they have engaged so far. So by leveraging such data, we can infer from the people's reaction to such like interaction experience. So right now I'm browsing through the feedbacks, and we see that people sometimes are commenting on, okay, oh, this term, and sometimes they comment, okay, the language model is not like, so the CoStorm is not like following me when I try to steer this conversation to some extent. So by doing that, we can like kind of, so that is the problem, like, in the wild evaluation, like we cannot enforce all the people to give comments on each turn, but we can infer from some feedbacks, general feedbacks people leave. Like you can imagine people leave comments when they feel something is really great or they feel that is really bad and I want to complain. And that is some hint we can leverage and to do in-depth analysis. And since in Storm we collect like large enough like batch of feedback, it can also like provide some insights and statistical significance to some extent.
But I'm suggesting maybe I think there is a gap on because usually when we get data of this kind and we don't go through any kind of reliability check, we find that you're reporting a lot of outliers, hence your p-value is scored at any point. So maybe an improvement I can suggest here is to look at reliability checks when you are reporting Likert scale data set of this kind, because it is a problem I've seen at several levels. However much the sample size can be, it has an impact.
Mm-hmm.
So us going through both alpha as one of the reliability and the variety checks for this kind of data, it gives you productivity for the reports you have to make, and it helps you to avoid bias. So I'm saying that's an improvement in this case to look through the reliability checks in this context.
Mhm.
Thank you.
Yeah, that's a very good suggestion.
Thank you, Dixon. I don't know whether there are other members with questions, but looks like we have reached the top of the hour. And if there are no any other questions, I want to thank Yijia and Yicheng for really saving some time